Once again, good morning to all of you. Um, I think you were able to see my screen. I have projected the teaching plan. We are in the fourth module, over voltage and the insulation requirement. So already we have discussed about last class. We discussed about what is the reason for the over voltage happening in the transmission line. Over voltage simply won't occur in the transmission line due to some reason. The over voltage will takes place on the transmission line. There are three main reasons. One is lightning. There is an external um, reason or external variance or external factor which cause for the over voltage on the transmission line. We discussed about the lightning last class. And the second reason why the over voltage takes place on the transmission line is due to sudden opening and closing of the or connecting and disconnecting of the load. One example, last class I have quoted in our class when we are in the university, right? Suddenly, sometimes power supply will goes off. Then suddenly it will come, right? In a particular room or particular class, we will have maybe 9, 10 fans we have and 10 tube lights we have. It's a single room. Just think about the entire university. Not only light load, lab might have functioning, the AC, then other big experiment in the food processing as well as in biotech lab, mechanical lab. So lot of loads are running with the PNE or maybe utility center. Suddenly it goes off. Suddenly it will create a huge surge. Right? This is another reason. Right? So for coming classes, we will see how to quench or how to arrest such kind of surges. What are the equipments we need? We supposed to provide in the particular places. That all those things we are going to see. So this unit consists of what are the root cause for overvoltage. Second reason, first reason is lightning. Second reason is sudden increasing and decreasing of the load. Third reason is frequency fluctuation. Frequency fluctuation will also producing such kind of over voltage. The reason is, the transmission line is, in the transmission line we will have R, we will have L, we will have C. R is negligible, resistance is negligible. But we will have XL and XC. XL equal to 2 pi F and XC equal to 1 divided by 2 pi FC. Right? If the frequency is disturbed, right, resonance will take place. The condition for resonance, you might have studied in your electrical circuits. The condition for resonance is XL equal to XC. If this happens, resonance will take place. If the resonance takes place means my inductance capacitance will vary. Then suddenly voltage will be developed on the transmission. That will also cause for over voltage. So these are the things we have discussed last classes, and we are also today we are going to continue the same topic today. Maybe end of this week, I try to complete maybe 22 and 23. We will see. Okay, lightning. I want to refresh what we have discussed in the previous class. The positive cloud and the negative cloud will formed based on the charges available in the cloud, positive cloud as well as negative cloud. And mostly the lightning will take place between clouds, positive clouds as well as negative clouds. Sometimes or most of the time, maybe comparatively less time, the lightning will happen between cloud and ground. Cloud, ground, flash. Sometimes you might have seen when you are when we have the rain in our particular place, and sometimes we will have the spark between cloud and ground. In the sky, we will see there is a flash between cloud and cloud, right? But sometimes, but most of the time, another statistics we have seen 100,000 times is happening in the cloud, in the sky around the world, right? So these are the things, positive cloud, and when we have the negative charges on the ground, this positive cloud will be attracted by this one. Therefore, a discharge will take place that will form a beam, lightning beam, right? So that voltage, all those things. Last class we discussed about it. Just once again, I want to show. Lightning needs a specific kind of clouds during the thunderstorm. These are things. See here, 8 billion, 8 billion. So very numbers are so huge, right? Right now, so many lightning might have taken place in this sky, right? So sometimes I wonder about the creation, right? So huge universe, and that we have a lot of galaxies. It's beyond our imagination, beyond our knowledge. It's kind of, if you analyze all those things, right? The volt per beam is 1,000 millivolt, sorry, million volt, and electricity 200 kiloampere. 200,000 ampere, otherwise 200 kiloampere. There is no device to withstand such kind of huge capacity of the light. That is, we have to wonder about the creation and the creator also. Right? Yeah, we will come to the second reason, switching surge. Right? Please note down what I have shown. Please note it down in your notebook. Then after that, I will explain. Second reason for over voltage. This is internal factor. Internal factor. Reason for switching surge voltage surge: sudden opening of the line, sudden closing of the line. That means connecting of load and disconnecting of the load. And sometimes connection of inductance, connection of capacitance. That means sometimes we will, okay, you please get noted down. Okay, first reason, sudden opening and closing of the transmission line. Okay, for example, one particular line may get damaged, right? Maybe between all of the rating to right? Few lines may be disturbed. Then some bypass line we are having sometimes. Using this particular line, the current will reach Karanya. Actually, current reach to Karnia University is from Madhumadi to Alandare, Alandare to Karnia in this way, right? So we will have some bypass line also we will have, right? So that will bypass some, for example, some. Otherwise, what will happen if something is happening in the Irritapallam? After the Irritapallam, every load will be shut off. We don't have power at all. Why unnecessarily this healthy line will be affected by the faulty line? Right? Therefore, sometimes they will, not sometimes, most of the time they will have some bypass transmission line they will provide. So during that, through that line, the power will reach current. Right? So sudden increasing or sudden decreasing of the transmission line will also cause for surge. Then second thing, connection of inductance and capacitance. I already said, so sometimes reactive power, unused reactive power will flow from sending end to receiving end. Unused reactive power. Further, we supposed to put some capacitor, filter, LC filter in the middle of the transmission line. Already I have told, right? So if I'm adding such kind of L or adding such kind of C or removing such kind of L, removing such kind of C will produce voltage surge. That's the second reason. Third reason is sudden increasing and removal of or decreasing the load, right? Removal and adding of transmission line, removal and adding of L and C, removal and adding of load. These are the three major reasons cause for voltage surge happening in the transmission line. Then, fourth reason, any sudden disturbances taking place in the transmission line will cause switching surge. Sometimes during the rainy season or stormy or windy season, right, the tree may falling on the transmission line, right? So because of that, short circuit takes place, voltage surge will take place. So these are some few reasons. These are few internal reasons which cause for voltage or switching surge. Further say. Right? For the range of values of the inductance and capacitance of the overhead transmission line, the frequency of the switching surge are generally in the range of kilocoulombs per second. Right? I mean, just like that, the charge, coulomb is nothing but charge, right? So, so many electrons, flow of electrons will be there in terms of kilocoulombs. So much electrons will flow from one end to another end per second. The duration is millisecond. Such kind of hike in the voltage surge will happen. Duration is few milliseconds. After that, it will be okay. If the duration is more than a second, then it will come and hit my home appliances or maybe huge transformers. Huge transformers. For example, if you go for a clinic to take some injection from the doctor, right? The doctor will give an injection that may be happening on the duration may be hardly 3 seconds or 4 seconds. Within that, he give the injection and take the injection out. But if the duration is keep on increasing, maybe 5 minutes, keep on they are giving an injection means we cannot tolerate, we cannot bear the pain. The same way, such kind of over voltage that the small, maybe millisecond, your transformer winding may carry such kind of huge current as well as huge voltage for a millisecond. Right? If it is more than a millisecond, maybe a 1 second or 1.5 second, my transformer windings will burn. Overheat will take place. It will evaporate the transformer oil, and the winding will lose their insulation, and short circuit takes place.